Hi everybody, it's Mrs. Mancuso and we are on to the next part of nuclear chemistry. So we're in week 2 and this time we are going to be focused on half-lives. So half-lives is the amount of time that it takes for half of a sample to naturally decay. All right, and you can't change a half-life, like you can't speed it up or slow it down. So let's say I have 100 grams of this sample. The amount of time that it takes for it to change into 50 grams, that would be its half-life. How much time does this decay take? So we have it all listed for us. So right here are the half-life times. And remember, it does not change. You can't heat it up. You can't lock it away. Like there's no way to change the half-life. It will happen over that time period. Some of them are in days, some are years, some are milliseconds, some are minutes. So it really varies, even hours, based on the substance. So if it's milliseconds, it has an extremely short half-life, and if it's years, it has a very long half-life. And so some radioisotopes are actually dangerous, so we don't want them around us in the air. So when there have been some nuclear explosions from power plants and things like polonium are released into the air, they know that that can actually cause lung cancer. They know it can actually cause thyroid cancer. So when they know that these radioisotopes can alter DNA, they're very concerned about them being in the atmosphere, being exposed. So you can hide them away. They're still going to decompose, but at least you can cover them. So in places like Chernobyl, where they had nuclear explosions, they would put them in what they call the sarcophagus. They would cover them with lead. We know lead is one of those things that helps stop particles from traveling. And so they put them in lead and cement and all sorts of layers to try and protect them. But I'm going to move on to half-life problems. So you're going to be spending all of this week's work doing calculations. So I think you've probably learned some of these before. You're definitely going to need a calculator and your reference table. So grab that if you don't have it. So the first one is, if it's not one of the ones listed on table N, or they haven't told you what it is, how do you find the half-life? So if 25 grams of a 100 gram sample remains after 30 seconds, so 30 seconds is the total time that's gone by, what's the half-life? So I start with 100 grams. After one half-life, I would have half of that. So half of 100 is 50. That's not 25 yet, so I got to keep going. After 2 half-lives, I would have 25. Awesome. So I know that I have undergone 2 half-lives in 30 seconds. So if 30 seconds have gone by and I've done 2 half-lives, then that's equal to 15 seconds. 15 seconds is the length of the half-life. So I take the total time that's gone by. I figured out how many arrows it would take, how many half-lives it would take. It took 2. So this was 15 seconds and this was 15 seconds, though 30 seconds had gone by total. All right, the next one. If 15.625 grams of a 250 gram sample remains after 5,280 years, what's the half-life? So there's the total time that's gone by. I need to start with 250 grams. All right, again, you might need a calculator to do this. After one half-life, I'd have half of that. So take 250 divided by 2 and you get 125. I want to get all the way down to 15.625. All right, so I got to keep going. After 2 half-lives, I'd have 62.5 grams. Not done. After 3 half-lives, I'd have 31.25. Still not done. After 4 half-lives, half of that would be 15.625. Yes, that's what I wanted. So 4 half-lives have gone by. The total time that went by was 5280. So all of this was 5280. So 5280 divided by 4 is going to give me 1,320 years. That's the half-life. 1320 times 4 would bring me down to a 250 gram sample, becoming only 15.6 grams. All right, another type of problem, finding the time that has gone by. All right, 60 grams of Fe53 has decayed till only 7.5 grams remain. All right, let's figure out how many half-lives that is. Start with 60. After 1 half-life, I'd have 30. After 2 half-lives, I'd have 15. And after 3 half-lives, I'd have 7.5. Okay, that's what I wanted to get to. So I know 3 half-lives have gone by. So I'm going to look up Fe53. Fe53, 8.51 minutes. 8.51 minutes times 3. I've done 3 of these 8.51 minutes. That would give me 25.53 minutes has gone by. So I just multiply. I figured out how many half-lives have gone by. I figured out the time of 1 half-life by looking it up. So I multiply that by 3. If only 25 grams of an 800 gram sample of cobalt-60 remain, how much time has passed? All right, start with 800 and get all the way down to 25. So after 1 half-life, this would be 400. After 2 half-lives, it would be 200. After 3 half-lives, it would be 100. After 4 half-lives, it would be 50. And after 5 half-lives, it would be 25. Okay, 25 is what I wanted. 5 half-lives have gone by. Now I got to go look up cobalt-60. There it is, cobalt-60, 5.271 years. Times 5. So I multiply 5.271 times 5 and I get 26.355 years. That's how much time has gone by, because that's 5.271 years, that's 5.271 years, so I multiplied it by 5. All right, the next type of problem, finding the grams that remain. All right, how many grams of a 100 gram sample will remain after 4.92 seconds? So if my total time that's gone by is 4.92 seconds, I want to divide that by how long is 1 half-life. So K37. Here it is, K37, 1.23 seconds. All right, so I divide 4.92 by 1.23 and I get 4. So 4 half-lives have gone by. I start with 100 grams and I need to break it down 4 times. So after 1 half-life, I would have 50. After 2 half-lives, I'd have 25. After 3 half-lives, I'd have 12.5. And after 4 half-lives, I'd have 6.25 grams. There's my answer. So I figured out how many half-lives and I did that many arrows and that told me how much. All right, how many grams of a 300 gram sample of SR90 will remain after 87.3 years? If 87.3 years have gone by, first thing I'm going to do is divide it by the half-life of SR90. So I got to go find SR90. Where are you? There you are, 29.1 years. Okay, so I divide 87.3 by 29.1 and I get 3. So I start off with 300 and I want to have 3 arrows. After 1 half-life, I would have 150. After 2 half-lives, I would have 75. After 3 half-lives, I would have 37.5 grams. That's how much would remain. All right, last type of problem that you see when doing half-life problems, finding the fraction that remains. So if they don't give you the actual amount of grams, you can just figure out the fraction, like does half of it remain? Or 2 halves, that would be a quarter. How much would remain? So what fraction remains after this many years? Okay, 9.64 times 10 to the 4th. All right, PU 239. PU 2.410 times 10. Okay, when you're dividing by 10 to the 4th, these literally will cancel each other out. If you like to make them into whole numbers and do it first, you can, but those will cancel each other out. So I divide and I get 4. So 4 half-lives go by. So I just do 4 halves. 1, 2, 3, 4. 2 times 2 is 4, times 2 is 8, times 2 is 16. 1/16 will remain. 1/16 of my sample. All right, there is a way of checking this as well, or you could do your other math this way. So let's say I had 100 grams. After 1 half-life, that would be 50. After 2 half-lives, that would be 25. After 3 half-lives, that would be 12.5. And after 4 half-lives, that would be 6.25. If you take 100 times 1/16, it will give you 6.25. So it is another way of doing the problems asking you how many grams remain. If you don't like doing all of the arrows, you could always do this, figure out the fraction and multiply your starting value times this, and it will give you the same answer. All right, let's do this last one. What fraction of an RN222 sample will remain after this many days? Okay, 11.469. I got to go look up RN222's half-life. There it is, 3.823. Both of these are in days. Really important to make sure that those match. All right, I divide and I get 3. So 1, 2, 3. 2 times 2 is 4, times 2 is 8. 1/8 of my sample will remain. All right, that's it. If you have questions, make sure that you message me. And remember, every Friday at 1, you can do review with me on Zoom. Bye.